was the ultimate challenge. Soap Lake Siphon, the largest structure of its kind in the world when it was built, was in trouble. Grand Coulee Dam on the Columbia River in Washington State provides the headwater for the 2.5-mile siphon, which feeds the West Canal of the massive Columbia Basin Irrigation Project. It provides the elixir of life for thousands of acres of some of the most productive farmland on Earth. The problem was in a 1.5-mile long section of the siphon made of steel-lined concrete pipe. This section was showing serious signs of aging. The pipe's protective coating was breaking down. Corrosion and mineral deposits had already begun to cause flow losses, and more serious problems loomed in the future. The Bureau of Reclamation decided the solution was to rehabilitate the siphon with in-place cement mortar lining. They called on Spinello Construction's Cement Mortar Lining Division. It quickly became clear that this was no ordinary project. The first hurdle was the sheer size of the pipe. At 22 feet 4 inches, this pipe would be the largest ever considered for rehabilitation by cleaning and cement mortar lining. In addition, parts of its 8,200-foot length had a slope of 18%. Also, downtime on the siphon was limited to 120 days, which meant the project would have to be handled in 2 stages. Spinello's first step to ensure the successful completion of the job was to mock up a section of the pipe in its Southern California shop. Substantial modification was required to all the systems related to the mortar application: troweling, conveying, mortar batching, and mortar mixing systems were adapted and tested on the mock-up, then shipped to the work site and reassembled. The required amounts of sand and cement were also placed at the work site and distributed along the length of the siphon where they would be used. Cleaning of the pipe was to begin as soon as it was drained. However, assessment of the condition of the original lining delayed the cleaning. This in turn set back the schedule for the setup and testing of the mortar lining equipment. Still, because of Spinello's superior project management capabilities, the job was soon back on schedule. Placement of the mortar began with the positioning of the equipment in the pipe at the lowest point of the section to be lined. Specifications required a lining 3/4 inch thick, which had to be placed on a surface more than 11 feet away from the revolving application head and applied on a surface that was also nearly flat because of the large diameter of the pipe. Due to the effect of gravity on the projection velocity and the weight of the wet mortar, the 3/4 inch lining had to be applied in 2 3/8 inch courses. The steel surface was specially treated to accelerate the setting of the mortar for the first course, which was applied without troweling. The untroweled surface provided additional adhesion for the second troweled course. Applying an exact thickness of 3/8 inch required every aspect of the lining process to mesh flawlessly. The most crucial factor was precise control of the rate of travel of the lining machine. This affects the amount of mortar that is applied per unit distance, as well as the rate at which troweling takes place. The mortar must be troweled within 1 minute of its application. Trowel tension must be precisely and properly adjusted to provide adequate pressure for proper surface texture. Excess trowel pressure can cause the wet lining to fail to adhere. Also crucial, of course, is supplying adequate amounts of correctly mixed mortar to the equipment at all times. Specially designed equipment transports 3,000 pounds of mortar 500 feet in 1 minute. About 20 minutes elapse from the time the mortar is first mixed. During that time, the material receives additional mixing to improve its elasticity and dispel some of the heat of hydration, which helps prevent curing shrinkage. The end result is a smooth, uniform surface that restored the interior of the pipe to a condition that's better than new. Spinello Construction met the challenge of the Soap Lake Siphon head on. The result of the rehabilitation effort was restoration of full flow to the structure. What's more, the work assures that the siphon can continue to function at full capacity for many decades to come.